You've seen them, I've seen them, we've all seen them. Those absolutely mind-blowing videos from AI models like Sora and Pika. You know, a few seconds of pure visual magic. But have you ever noticed they just stop? Well, let's get into exactly why that happens.
I mean, it's the big question, isn't it? If an AI can whip up a stunning 30-second clip, what's really stopping it from creating a 30-minute episode? Or heck, a full-length movie? Turns out the answer is way more complicated than you'd think. In the research world, they've actually given this problem a name. They call it the 1-minute wall. And it's this kind of invisible barrier that even the most powerful, state-of-the-art systems, yeah, even Sora, can't seem to punch through. Once you get past that 60-second mark, things just start to get weird.
Okay, to really get a sense of how massive this challenge is, think about this. A single minute of video, running at 30 frames per second, has 1,800 individual pictures. The AI's job isn't just to make each one look pretty. It has to make every single frame perfectly consistent with all 1,799 others. That is a colossal feat of memory and logic.
And the moment that consistency breaks, the whole illusion just shatters. You start to see this weird flickering. Characters and objects might slowly drift or change shape for no reason, and the plot just stops making any sense. It's a problem that researchers call semantic discontinuity.
So the really critical thing to understand is why this is happening. The root of the whole problem is in the old-school approach, using one giant monolithic AI model to do absolutely everything, from understanding the script to painting every last pixel. This one-size-fits-all method, it just isn't built for a marathon.
In fact, researchers have nailed down 4 specific ways these giant models fail. First, they totally struggle with basic physical correctness, gravity. Second, the shading and light just go all over the place, which completely ruins the sense of a real location. Third, the camera can start flying around like crazy for no good reason. And last, you get that awful flicker and drift, the thing they call temporal inconsistency.
And look, this isn't just some small technical glitch we're talking about. As this quote makes super clear, creating long videos is one of the absolute toughest challenges in all of AI research. It is a fundamentally harder problem to solve than just making a cool short clip. But here's the cool part. What if we stopped thinking about it as one giant AI brain and started thinking about it like a whole team? This is where a totally new approach comes in, the multi-agent system. And honestly, the best way to think about it is like assembling an AI film crew.
The idea is just brilliant, and it's actually pretty simple. Instead of one AI trying to juggle everything, you have a team of specialized AIs. One agent is the director, another one is the cinematographer, and another one is the editor who reviews the footage. Each one has a very specific job, and they all have to work together.
So, how does this AI film crew actually go about making a video? Well, it's not just a bunch of AIs running around. It's a really structured, collaborative process that takes an idea all the way from the planning stage to the final cut.
This crew works in something called a creative loop. First, the planning agents, the directors, break down the story. Then, the generation agents, the camera crew, create the visuals. Now, this next part is key. Evaluation agents then watch that footage, checking it for quality and consistency. Based on their notes, the team refines the work and does it again and again until it's just right. So let's just quickly break down those main roles. You've got the planning agent, that's your director mapping out the whole vision. Then you've got the generation agent, that's your programmer or cinematographer who actually makes the thing. And finally, you have the evaluation agent, your reviewer, who makes sure everything is up to snuff.
And the amazing result of all this teamwork isn't just that the videos are longer. What this new method unlocks is this incredible combination of both wild, sprawling creativity and razor-sharp accuracy. It's something a single model could just never pull off. And we're already seeing this work in the real world, with pioneering systems like Dream Factory and Kubrick. You can think of Dream Factory as kind of like an indie film crew. It's great for telling stories and making creative shorts. Kubrick, on the other hand, is more like the technical crew for a big science documentary. It uses 3D rendering to get perfect physical accuracy. Different crews for different kinds of movies. Makes sense, right?
And hey, the results, you can actually measure them. Take a look at Dream Factory's scores on these key consistency metrics. CSSFD basically measures if a character's face stays the same from one shot to the next, and CSSC measures if the visual style, the look and feel, is consistent.
On both of these, the multi-agent system just blows the old single model approach out of the water. The proof is right there in the data.
But here's where it gets truly fascinating. This collaboration doesn't just make things more consistent, it actually sparks creativity. By mashing up different AI perspectives, or even having some agents challenge the ideas of other agents, the system can stumble upon visual solutions that a single AI just thinking by itself would never, ever come up with.
This quote just nails it. This kind of structured teamwork leads to what's called emergent creativity. It's not just the sum of the parts. The interaction between the agents creates something totally new and unexpected. It's pretty amazing.
So, beyond all the cool creative stuff, this multi-agent system also unlocks a whole new level of accuracy. You see, for a video to feel real, it needs something called spatial-temporal consistency. I know, it's a mouthful, but it's really just a fancy way of saying that the world inside the video has to follow a consistent set of rules, just like our world does.
The first rule is object permanence. It's super simple. If a character walks off the screen and then walks back on a minute later, they need to be the same person. They shouldn't have suddenly changed their shirt or, grown a beard. The AI crew has agents whose only job is to track this stuff.
Rule number 2 is physics-based motion. A ball that gets thrown should travel in an arc, not a zigzag. Water is supposed to splash, it shouldn't freeze in midair. The world has to feel like it has weight and consequence, and there are specialized agents that make sure that it does.
And the final pillar is lighting continuity. Look, if a scene is taking place at sunset, the shadows have to be long and the light has to be warm, and it needs to stay that way for the entire scene. It's this kind of consistency that makes an environment feel real and totally immersing.
Okay, so with this 1-minute wall finally starting to crumble, we really have to ask ourselves, what does the future of storytelling even look like? Where is this all headed?
Well, right now, these systems are pushing toward generating a coherent 10 minutes of video. The immediate next step is creating standardized tests so we can all agree on what good actually looks like. But the long-term vision, it's just breathtaking. We're talking feature-length movies created by a seamless collaboration between a human director and their AI film crew.
Which, of course, leads to this final fascinating question. The slide asks if an Oscar winner will thank an AI director. But, maybe the more interesting question isn't if an AI will get thanked, but how this technology changes the very definition of what a director is. We are watching AI evolve from just being a tool like a camera to becoming a true collaborator. This could fundamentally reshape the entire creative process, making filmmaking accessible to way more people, and transforming storytelling into a genuine partnership between human vision and artificial imagination.